So this week looks insane. Like, you actually have a quiz on Thursday, which means your homework packet is due Thursday. But here, listen to everything I have to say. Before you get cranky at me, listen to me. Seems reasonable, okay? I have no problem moving that quiz till Friday whatsoever. Content-wise, we've actually already done 2 sections. You just didn't have the homework packet yet. Okay? So from that perspective, if you guys want to move the quiz to Friday, couldn't care less. Your test over this last unit, Unit 4, is Monday and Tuesday of next week. So the reason I put the quiz on Thursday is so that you could get it, I could grade it and get it back to you on Friday. So that you would have feedback on that content to study for the test. Okay? So, today's notes do not come anywhere close to taking the whole time. I can either end when I was planning on ending, or I can keep going through the integrating trig functions notes. Okay? That's what the morning class chose. And then you'll have almost the entire block period to just work through that homework packet. Okay? So, I can do that. That's not a problem. So it feels like a lot right now. And then if you guys are getting through Wednesday and you're like, Meister, we can't get this done, we want to take the quiz on Thursday, that's fine. Or Friday, I couldn't care less. To me, that is, and if people want to take the quiz, even not take the quiz Thursday and then take the quiz during study hall at some point so that you can have it back for Friday, that's doable too. You guys, I'm hoping you guys are understanding now that I am, whatever I can do to make it easier on you guys, I will do within the parameters I've got to live in. Does that make sense? Okay, how many of you guys are in singers? Singers?
No.
Is Quinn?
Quinn is not singers. It's just Ellen and Daria.
Okay. So your guys' musical performance schedule happens to be the middle of finals week.
Yeah.
It's almost half of the morning class that are in singers, so they're opting to do something. What they are opting to do is take the final the week earlier. And then do the bonus coverage after the final. Let's look at your performance schedule, and we can do that with you guys if you want, or however we want to do it. But we need to be looking at that. Because, he puts it in that week so it doesn't conflict with midterms for all your guys' other classes, but it kind of puts the Columbus State courses in a little bit of a bind. But we'll work around it. I'll be flexible, but I want you guys to start thinking about it now and come up with some potential solutions. I don't need to be available for you guys to take the final, right? So it's just a matter of looking at that week and when or some time frames. It'll take 3 days. Or for you, it'll take 3 42-minute class periods. So I don't know if you guys have a performance on the block day. I'm pretty sure you do. I'm pretty sure that's one of your 3 performance days. So just kind of keeping that in the back of your mind, and we need to, I'm giving you a month's notice that we need to plan around it, is basically what I'm trying to say. And you guys will have some opportunities to I'll check in with you about, let's make that plans. And it can be customized to each of you individually. It's not a problem.
Is this our last content unit then?
This is our last content unit.
Okay.
We take the test on Monday, Tuesday. Then we have Thanksgiving break.
Wait, when does Thanksgiving break start?
Then we do the bonus coverage. Then we take the final and we're done. So we only have 2 weeks after Thanksgiving. One of which you're taking the final pretty much the entire week.
That sounds fun. What's the bonus stuff?
It's stuff that doesn't have to be on the final, doesn't have to be on any unit test, but is on the syllabus. And it's stuff that I cut out. I didn't want you guys confusing it for tests. That's why the other class is choosing to take the final early, and then doing the bonus coverage. So then they're just coming back and reviewing for the final. What that would likely look like is that for the first, you would have the Monday coming back from Thanksgiving, the Monday and the block day to review. And then the final would be Thursday, Friday, the following Monday. And that shouldn't interfere with you guys too much. And then those last 4 days of the semester, you would have a small homework assignment that would not be worth a ton of points over the bonus coverage that I would try to crank through as quickly as possible. And frankly, might even make those videos in advance. I could make those as videos in advance and then just say the homework's due by the end of the semester. Maybe that's how I do that.
Can we take it, we can't take it the week after, right?
No, because my grades are due to Columbus State before that.
What do we do after, like, what is the end of the,
Once Columbus State semester is over,
yeah, when is that? Is that like the 12th or something?
mm-hmm,
Okay. I was right. Wow.
you are not required to be here.
Oh, wow. That's interesting.
It is study hall, and you guys are seniors.
Let's go, then I'll have 6th and 7th. Let's go.
Now, I will be here, so if you guys just want to hang out and stuff, we could totally just hang.
Do we have a class?
I'll probably just hang.
If you guys want to have a class party, we absolutely could.
Oh, that'd be so
That'd be
good.
fun, actually. It's like we did it in chem. That was
Okay, so my plan is, you guys, from here on out, I'm going to kind of cruise a little bit. My intention is that we get as far as we can so you have as much of the block period to just work through that homework packet. And like I said, at the end of the block day on Wednesday, if you have concerns about taking the quiz on Thursday, no problem, we'll talk. It's like I will be flexible. I'm pretty sure you guys know at this point that however I can be, I will be for you. Hey, what's the integral of sine? What is it?
negative cosine.
Negative cosine.
U plus C.
Plus C. What's the integral of cosine?
Plus C squared.
Times pi.
Because they're all constants.
You guys, what is the integral of tangent?
I don't know. Oh, we did this.
You did. You did.
Is it secant tangent or something? No.
It's something.
This is outrageous.
L.
Oh, it's 1 plus.
No, it's like the ln or something.
No, it's like an equation. I can't remember this equation. It makes me upset.
Let me just.
Negative. Oh yeah, we have to put the negative on the outside.
Do we want the proof real quick?
No,
Yes, please.
This is the integral of sine u over cosine u du. So if you let your u equal cosine u. Wait, you guys, and this is stupid. I'm going to make x equal to cosine u because since it's written in terms of u, I'm doing x substitution instead of u substitution. So we get dx equals negative sine u du. So I'm integrating negative 1 over x dx. And then, do you want me to keep going with that? So how would the integral of cotangent be different from that? It'd be the integral of cosine u over sine u du. So now what am I using as my substitution step? X equals sine of u, meaning dx is cosine of u du. Everybody good? And let's see, so from there I've got the integral of 1 over x dx, which is natural log of x, plus c, which is natural log of sine u plus c.
Can you say where you're getting the 1 over x?
Yeah, so the cosine u du, these two things become dx, and then x is equal to sine u.
Oh, okay.
Cool?
Yeah.
All right. So far, we kind of have 4 integration rules. These are the 4 I do not memorize. I'm going to show you the proof for the next one. I would memorize it. I memorize it. I know the proof, but I memorize it. Everybody with me? Because the proof is not a natural proof
For the secant.
for the secant. Yeah, it's not something, what you end up doing, it doesn't make, there's no reason looking at it that says you should do it. I just happen to know that it works and it therefore is a good proof. I know that feels really icky. But can you guys just trust me on something, you know? Okay, so to integrate secant u. The first thing you're going to do is rewrite this as secant u. And you're going to multiply both the top and the bottom by secant u plus tangent u. Everybody good? Mm-hmm. And then we essentially get secant squared u plus secant u tangent u. So, such a natural thing to do. Okay, now, from here, we're going to do a substitution step. And it makes no sense that we multiplied by that secant plus tangent. However, the minute we did, what is the derivative of secant plus tangent? Well, the derivative of secant is secant tangent. The derivative of tangent is you guys, do you guys see that the derivative of the numerator, or that the numerator is the derivative of the denominator now that we've taken it? So all of a sudden this becomes 1 over x dx. Do you guys see it? So the integral of secant, so I get ln of x plus c is really ln of secant u plus tangent. Not secant tangent, but secant plus tangent plus c. Not an obvious thing to do. I recognize it's not an obvious thing to do. Once you know that one, does anybody want to hazard what the integral of cosecant is?
1 over this
Negative.
or
Negative
negative?
ln of cosecant u
Or can we
plus
just know that?
cotangent u.
This
Yeah.
one? Okay.
If you recognize that the cos are always the negative of the regulars, that's how you end there, right?
U plus cotangent u.
All right. So, like this, everything else is going to feel hairy with this, but essentially, this is what's going. Like, as long as you can remember that the integral of secant is the natural log of secant plus tangent, which is not an easy thing, but those are the only ones you actually have to memorize if you want to use u sub for the tangent and the cotangent. It's really not as bad as it looks, okay? All right. Now, how might I ask you these questions? I'm not going to ask you to write the proofs out. You don't need to memorize that proof by any means. You guys, what is, how would you guys do this one? We have an inner and an outer function, and in fact, what is the derivative? The ln t is plugged into that cosine.
Yeah.
The derivative of ln t is 1 over t dt, which I also have, yeah? So this all of a sudden has become the cosine of u du. And the integral of cosine is Are we feeling okay? What about this one? No, 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 no.
The square root of theta
U equals square root theta. Du equals 1 over 2 root theta d theta. This is looking pretty nice.
It is.
So are you guys cool if I say 2 du equals d theta, over the square root of theta? Because then this is like
2du. Wait. So I have to think about this. Never mind. I don't have to think.
What do you guys think? Is this okay?
It's okay.
It looks worse than it is, yeah? Speaking of looks worse than it is, let's look at inverse trig functions.
Oh my god. Sorry.
Looks worse than it is. You guys, for the quiz and the test, I am going to give these to you.
Nice.
Not on the final.
I don't have a choice on the final. There's no resource sheets allowed on the final.
Oh, so that means we have to memorize all like the end stuff.
That stuff's not on the final.
Oh. Oh.
Inverse trig function, this stuff could be on the final.
Wait, so what?
The sums are not. Okay? So like you don't need to memorize them for Thursday's quiz. You don't need to memorize them for the test next week. You do need to be familiar with them for the final. Okay?
Can we go over which things are on the final?
I will happily tell you a few things that are not.
Yeah, like, that's like what I.
It'll be
things
more
not-
like it'll be more that I will tell you what is not on the final
Yeah.
than I will tell you what is on the final.
Yeah, that's kind of. But
Okay.
What do I not study?
You guys, the trick to all of these is going to be identifying what is your A versus and what is your U for these formulas, okay? So, as I'm looking at this, A is always the term that is constant and U is a function. So, when I look at, say, this question, are you with me that all of these have denominators with squares in it? Okay. So when I say what is my A, I'm looking in that denominator. I'm looking for the constant. And A is the square root of that constant because A squared is equal to the constant. So you guys, for this one, what is A? 1. What is U?
3x.
The U is 3x. Because it's U, because when we look at these formulas, that is U squared. Is everybody good? So if A squared is equal to 1, U would be the 9x squared, or U squared would be 9x squared. So to figure out U, I would take the square root. Is everybody good? That will become second nature by the time we work all the examples, you guys, okay? All right. So we're going to do one more thing. What does that tell us du is? 3 dx. So dx is equal to du over 3. All right. Now, here's what I'm going to do. I'm going to pull the 12 out front. I also have a 1/3 out front. Then I have the integral of du over a squared plus u squared. Which one does this look like?
1 over a arctan, whatever it is.
1 over a arctan of u over a plus c. Is everybody okay still?
Yeah.
Okay. You guys, what is the value of 1 over a?
1.
So I'm going to take that out so it doesn't look like a 41. What about u over a?
3x.
So it'd be arctan of 3x plus c.
Why are we doing this again? Why can't we just plug in? Like, is it just because it doesn't work? Or like,
When you say just plug in and then you stopped, right?
Sorry,
And then you
I
said
find the
it
best
doesn't
way
work.
to
So
articulate what I'm trying to ask.
like you want to try to do a u sub
But
of
it's
some
not
kind.
gonna work, right? Because of the squared or what?
So what would need to, so you want to do a u sub, I'm assuming, right? So if you did that u sub, my guess is you would do 1 plus 9x squared, right?
Oh, and it doesn't.
It's that x that makes u sub not make sense.
Okay.
So like it's not wrong to want to try a u sub in this scenario. It's just that as you go through and do it, it's not going to work.
Okay, cool. And the giveaway for that is this 1 plus something x squared.
Yeah.
Okay, cool.
So these functions are the derivatives of the inverse?
Correct.
Okay.
These are the derivatives. Yeah, and we did actually do this. We didn't do them with a squareds. Like they were usually much better, more behaved functions. Everybody okay? All right, let's look at another one. Wait, what's this one? What's B? Yeah, let's look at this one next. You guys aren't ready. You're going to punch me in the nose for that one.
Are we ever getting nerf balls?
Huh?
Are we ever getting nerf balls? Because you keep saying that, but
We discussed
it seems
this.
like you don't actually want stuff to be thrown at you.
Anyway. Again, we're going to want to do u equals and a equals.
Equals 3x.
U is the 3x. A is 5. So the a squared is 25, yeah?
Where did the 3x come from? The square root of?
Yeah, so this term is u squared. So what squared gives you the 9x squared?
But isn't like on the whatever the formula thing, the use in the front?
We'll get there.
Oh,
Okay.
man.
Chloe, you're not wrong.
It's
Okay.
gonna be a.
I'm just confused.
I know.
That's what I was.
Are you guys comfortable with me also saying that x is equal to u over 3?
Okay.
And that would make dx equal to du over 3. If I wanted to think of it that way.
Okay.
Cool? All right, so let's start filling everything we know. I'm going to call that x u over 3 times the square root of. And then I would have u squared minus a squared du. Which is also over 3, is that right? Yeah. Yeah.
Could we not put the 1/3 up front?
Oh, we can. We can, but I'm not going to. Everybody good? Everybody good with what I got so far? Here's why I'm not going to. If I kind of wanted to, I could look at this denominator like this, and then these 3's could cancel each other out.
Cancel? Why would they cancel?
Because this one's on the, because this is a over 3 and this is above 3.
Oh, that's being divided by over 3.
That'd be then like a top.
So now I'm at the integral to 1 times du over the square root, or u square root, u squared minus a squared. I could think of it that way, yeah.
Where'd you get the D for the 2? Oh, I see.
You guys ready to do the next one? Do you guys mind if I do a little sidebar for a second? A little algebra review. Do you guys remember the process called completing the square? You did it.
I don't remember I remember not liking it.
I was like 3 years ago.
First of all, you guys, if this is a perfect square, so this would be x plus something times x plus that same thing would give me x squared plus 6x plus something, yeah?
3.
These would have to be x plus 3's. Is everybody cool with me saying that in order for that to be a 6x, those would have to be x plus 3's?
Yeah.
Okay. So this is x. So what number would have been here? 9. So adding that 9 is called completing the square. Everybody good? All right. So what if I asked you x squared minus 10x plus something equals x minus something squared? What would that have to be?
5 and 25.
So it would be x minus 5, and this would be a 25. Okay. Why would I want to do this? Well, all of these have a function squared in them. Yes? So if I can rewrite it so that it is a function squared, then I can use these to get to my answer. So that's why I'm reviewing that. So I want to be able to take this and somehow write it as x minus something squared plus something. Is everybody with me so far? All right. So for right now, we're going to call this x squared minus 4x plus blank plus 7 minus blank. So if I'm only focusing on the completing of the square, what number needs to be here to complete this square?
16.
-4.
Oh.
4. Is everybody with me? I need to add 4 here. Can I just add 4 to the denominator? No. So that minus is also going to be a 4. So I'm going to add 4 and I am going to subtract 4. And in doing so, I can take those first 3 terms, call them x minus 2 the quantity squared, plus 3 from the 7 and the minus 4.
Yeah, that's.
So over here, we took half and then squared it. What's half of negative 4? Negative 2. Square it, I get positive 4.
Okay.
So essentially, when you complete the square, you're always going to divide the middle term in half and then square it for the last term.
Okay.
Is everybody okay? So now that I'm in this place, I can say a equals square root of 3. U equals x minus 2. Remember, it is the square root of both of those things, yeah? And the minute I do, and then I also have du would equal dx. So the dx becomes a du. The x minus 2 squared becomes a u squared. The 3 becomes an a squared. You guys, which of my inverse trig functions does this match? So it becomes 1 over a arctan u over a plus c.
Do you plug in these values?
Which then becomes 1 over square root 3 arctan of x minus 2 over the square root of 3 plus c.
Can we leave it that way?
Just leave it that way. I'm going to try to get through this one, and then I'll stop. So I did 2 things. I pulled the 2 up on top out front, right? And then to make the completing of the square easier, I pulled the negative sign out, yeah? So that it's in that same form. So if I do, what do I need to add here after I complete the square?
Plus 4.
Positive 4. Is that what I added?
What do you mean?
When I look at this plus 4, what I really added was
Oh, it has to be a negative 4.
a negative 4 because of this negative,
So
yeah?
to make it a minus 4.
So I have to counteract subtracting 4.
So you make it a minus sign.
So I would get plus 4 to counteract that. Is everybody okay?
Yeah.
All right, so now this becomes 2 times the integral of dy over the square root of 4 minus y minus 2, the quantity squared. How are we feeling? That's a lot of algebra. Once we do that, that was the hard part, yeah? So we have a equals and u equals. What's a? What is a? 2. U is y minus 2. Du is equal to dy. So this becomes 2. du over the square root of a squared minus u squared, which is? What is the integral of du over the square root of, what is it?
Arc sine.
Is it,
U of A.
so arc sine of u over a plus c. Done. See, that was easy. That's not easy. The calculus is actually the easy steps of this, right? It's the algebra that's frustrating. Oh, two. Yeah. So tomorrow, you guys, we're going to start with these examples. Okay? And then, I'm sorry, Wednesday. We'll start with these 4 examples, and you will have the rest of the time to work on your homework. I would recommend starting that homework before Wednesday, right? Like, I wouldn't just rely on Wednesday's class time to do it. Okay?